Hi everyone. Today we're going to be looking at solving circular functions using something called the general solution. And that's really just about knowing where your solutions will lie and then using that to solve for as many solutions as you need. Okay, now to solve any circular function, there's just some key steps that we have to follow. And one of the first things I want you to do is take note of your domain. Okay, that's where the solutions to your circular function are going to lie, and you cannot overstep that domain. All right. Now, the very first step that I want you to follow is to rearrange or simplify, depending on the problem you have, but rearrange or simplify what you have. Now, from what we can see here with root 2 over 2, it doesn't necessarily look like there's a simple solution to that, but if we divide both the denominator and the numerator by root 2, we actually end up with 1 over root 2, which we can solve pretty easily because we know that ratio. Now, using that knowledge we have of that ratio, our second step is going to be to identify the base angle. And that's the angle that we're going to be working with for all of our solutions. So in this case, because we've got sine of x is equal to 1 on root 2, hopefully we can see that would be a base angle of pi on 4. And that base angle is what we're going to use for our solutions. The third thing you need to do is identify the quadrant that your solution lies in, okay? And that's a matter of taking note, have you got a positive or a negative problem? And if that affects which quadrant we're in. So if we've got sine of x is equal to 1 over root 2, that means that our sine value is positive. So the two quadrants we're going to be lying in are quadrant 1 and quadrant 2. And it's really important that we learn to write, for general solutions, those quadrants in a general form, okay? Now, we know over here that we have all of our evens, so all of our 2 pi, 4 pi, 6 pi, etc. And the way we can write that in a general term is 2n pi, because 2n is going to give us all of our even integers. Now, same on the left-hand side here. We know that's all of our odd pi's, which is going to be the same as writing 2n plus 1 pi. Okay, and then hopefully you can see here that we're either adding or subtracting an angle from either of those. So by identifying the quadrant of our solutions, we can identify two of what we call general solutions. Okay, so our two general solutions that we're working with is x is equal to 2n pi plus our base angle, which is pi on 4. Okay, and that's going to give us our quadrant 1. And then our quadrant 2 is x is equal to 2n plus 1 pi minus pi on 4. Okay? This then leads to our fourth step, which is to sub in values for n until the domain is breached. So in this case, that means if I'm ever below 0 or I'm above 2 pi. In regards to my answers, okay? So let's start by subbing in n equals 0. That's always a really good place to start. And if we sub that in, we're going to have x is equal to 2 times 0 times pi, so 0, plus pi on 4. And that's one of our solutions. If we sub in n equals 1, we have x is equal to 2 pi plus pi on 4, which is 9 pi on 4. And that cannot be one of our answers because our domain has been breached, okay? Now we're going to start on the next side as well. We're going to sub in n is equal to 0. We get x equals pi minus pi on 4, which is 3 pi on 4. And if, let's say, we want to sub in n equals, let's say, negative 1, then we would have x is equal to negative pi minus pi on 4, which is negative 5 pi on 4, which breaches our domain, okay? So you're looking for your answers to be between 0 and 2 pi, and you need to sub in n on either side of the value, so you can do negatives, you can do positives, until you breach it on either side. Now, the very last step for this one is going to be to actually state your answer, okay? So you've done all this beautiful working out. you actually need to state the answer. So in this case, our answer is x equals pi on 4 and 3 pi on 4. And if you had the graph sine x equals root 2 on 2, those would be your solutions. Yeah. So now that you know how to do this, you'll be able to find the x-intercepts of any previous graphs, hopefully without a calculator. Now, feel free to pause this one here, but there is a little bit of a trick. So watch out for that square sign. Now, I'm going to follow that first step that I had, which was to rearrange or simplify. And I'm going to do that by square rooting both sides here. Now, the key thing to remember is that if we square root 3 on 4, we're going to have a positive and a negative answer. So currently we're working with cosine x is equal to positive and negative root 3 on 2. Okay. Now, using root 3 on 2, we're going to find our base angle. And in this case, our base angle, because of root 3 on 2, is going to be pi on 6. Okay. Now, because we've got both positive and negative cosine, we're going to be in every quadrant. All right, which means that our general solution is going to look very different. What this means is that our first general solution, which would be quadrant 1 and quadrant 4, we know that we've got 2n pi being our even, but because we're in both of those quadrants, it's going to be plus or minus that base angle of pi on 6. And then if we wanted to deal with quadrants 2 and quadrant 3, it would be x is equal to 2n plus 1 pi plus or minus pi on 6. Okay, so because we're in every quadrant, instead of dealing with these separately and having all of that working out, we're going to do plus or minus, and if we ever breach the domain at any point, we know to stop working with that general solution. Okay, so we are now going to sub in until we breach that domain. I'm going to start with n equals 0, and doing that would give me 0 at the 2n pi plus or minus pi on 6. So I know that I've got negative pi on 6 and I've got positive pi on 6. If I sub in 1, I would end up with 2 pi plus or minus pi on 6. If I have 12 pi on 6 plus or minus 1 pi on 6, I'd end up with 11 pi on 6 and 13 pi on 6, which, because of our domain being between negative pi and pi, we cannot have. Okay, so always, always, always take note of that domain. I'm going to check the other side just to be certain, but if I sub in x equals negative 1, I have negative 2 pi, so negative 12 pi on 6, plus or minus, I would have negative 13 pi on 6 and negative 11 pi on 6. And that also breaches my domain. Okay, so at the moment, I know that I've got negative pi on 6 and I've got pi on 6 in my solution. I'm going to do the same thing on this side here. I'm going to sub in n equals 0, and I end up with pi plus or minus pi on 6. I have 5 pi on 6, and I have 7 pi on 6, and now 7 pi on 6 breaches our domain. So we know that we also have 5 pi on 6 in our solutions, but 7 pi on 6 breaches our domain. Now, because the bigger number breaches our domain, we know that subbing in 1 is going to continue breaching it. So we're now going to sub in negative 1. And in doing that, we're going to have negative pi plus or minus pi on 6. So my two answers there are going to be negative 7 pi on 6, so negative pi take pi on 6. And negative pi plus pi on 6 is going to be negative 5 pi on 6. We can see once again, negative 7 pi on 6 breaches our domain. So my solutions are negative 5 pi on 6, negative pi on 6, pi on 6, and 5 pi on 6. So make sure that you follow the steps at the beginning. You should be able to solve any problem there, even if it looks a bit trickier. Rearrange to get sine of x or cosine of x by itself, or tan of x. And then find your base angle, identify your quadrant, and then sub in n until you breach that domain. And make sure at the very end to state your answer.